Our next talk is about protecting games against DDoS attacks by Metin Ozyildirim from Gcore.
Hi everybody, my name is Metin. I work for Gcore as a software engineer. So today I will talk about how we protect games and other infrastructure from DDoS attacks, and what we do as Gcore, and what we offer. Let's start. My agenda is I will start with Gcore's infrastructure, and I'll talk a bit about the threats in the gaming industry, and then it will be halfway non-technical. Then after the third one, it will be a bit more technical. So how we secure games with Gcore and how we can peer with your infrastructure, how we can connect your infrastructure to us. Let's start with Gcore's infrastructure. We have a point of presence in almost everywhere, like with 108 points of presence. We have over 200 terabits of network capacity. And we are offering our main product is CDN and cloud services. You can buy virtual machines, bare metals, or any kind of cloud stuff from us. Let's talk a bit about the gaming industry, because from our perspective, gaming is one of the most attacked sector in the DDoS attacks. So, according to our measurements, gaming almost takes around 50% of all attacks, all DDoS attacks. And the next is technology, telecommunications, financial services. But gaming has the biggest percentage in our pie. What are our main challenges in DDoS attacks? Well, it needs to be real time, because in games, if you guys have high latency, it will be perceived by the players. So it needs to be fast and low latency. And during events, sometimes during events, we get big attacks. So the protection needs to be always enabled. So we can't have some kind of protection which is sometimes not enabled, only enabled during attacks. We offer always enabled protection. Also, its network code itself is a challenge for us, because every game uses different protocol for multiplayer. So the protocol itself might not be very suitable for protection. It might be encrypted, it might not have the fields we use for better protection. So network code itself is a challenge for us. Also, threats are evolving every day. The attacks are getting more and more bigger and bigger. They get very volumetric, and also they get very complicated. Like they target specific games with their specific netcode, so attacks are getting complicated. And botnets are getting bigger too. They are creating higher volume attacks. To address all of these issues, we need to have a good infrastructure. We need high bandwidth available, so we can filter out these high volume attacks. Consequences, well, if you had attacks during events or during usual times, you will face financial loss, because once an attacker sees that they can stop your business, they can drop your players, they will come again. They will attack you again. So you will lose money, because your players are no longer playing your game. Your reputation will face problems. Your customers will lose trust to your company. They want to play more fluently. So sometimes also DDoS attacks are used for masking other attacks. Maybe they are doing some data breach, to hide it behind metrics, they will perform DDoS attacks at the same time. So it is important to filter DDoS attacks. Operational problems, they will cause downtime, they will cause problems across your infrastructure, you will lose players, and your IT teams will work harder to fix or patch the problems. Even a minor attack can cripple your game. To demonstrate this, I actually started a game server and I started an attack, very small attack. Like, it doesn't even cost me $5 to perform such attack. But it does disrupt the game. So we offer protection for these kind of scenarios. Now I will show you a video about the attack I recorded. How do I show this? This is Counter-Strike, so this is the same server and same attack. In the left side we have unprotected server, and on the right side we have protected server. Let's start it. So during DDoS attack, on the left side the game stutters. Like, if it was quite small attack, it was cheapest attack you can think of, but it will still cause problems. But with Gcore, we offer complicated protection against attacks, so it doesn't even affect anything during the gameplay. This is what this video is what players see, but during the attack, this is what we see. We see metrics about the attacks, like how many packets are there, what kind of packets are they, do they show specific patterns, or are they volumetric? This chart is from a terabit attack, so I mean, it's not possible to stop such attacks without a good infrastructure. It's very volumetric. This is smaller attack. This attack is way smaller than the next one, but it is very complicated. It shows patterns. It turns on and turns off, tries to avoid detection systems. It will still cause disruption, but in Gcore we offer always active protection, so even if it's under 10 seconds, 20 seconds, we still protect your infrastructure against such attacks. Securing games with Gcore. How we protect your games? We showed some stuff about what we do, but we didn't say how we do. I'll talk about how we do. Our main mechanism is cookie challenge. We try to distinguish between a real game client and a fake DDoS packet. How we do it? We put a cookie in the packets and we expect the clients to pass this challenge. And we do server query caching. Server query is probably most of you know. In the game server lists, there are details about game servers, like what's the name of the server, how many players are currently playing, what's the name of the map they are playing at. So we cache this information because this server information is the first point of attack for most of the attackers, because they see it's unprotected. You can get the details of the server without connection, without doing any connection. So we cache server queries, and we have stateless checks. These can be rate limiters of any kind, source rate limiters, destination rate limiters. We can do regular expression checks against packets, and we have a SDK which is a universal challenge mechanism. In case your protocol doesn't support cookie challenge, you can use our one. Let's talk about the cookie challenge. So once a game client does an connection attempt, it is not passed to your server. First, we catch that request and we respond it with a cookie. If the game client can successfully pass that pass, we will then allow it to connect to your server. So unless we validate a packet or a connection, they are not arriving to you. So this is the server query caching. We periodically query your server. We get the server name, map name, how many players are playing there. We cache it in our edge locations. Then once a game client asks for server information, we respond it from our edge locations. It allows faster responding, so it doesn't arrive to your protected server. It is protected and it is faster, answering faster. We have regex-based filtering and authorization. Regex is basically regular expressions. It is used for defining patterns. So if your packets are starting with specific sequence, in this example 52, 53, 41, 40, you can just use regex to define these patterns and allow only packets with these patterns. We can use this to allow, or we can use this to block packets. We have universal challenge. It's the same. It's working same as the cookie challenge, but in case your protocol doesn't have a cookie field, you can use our protocol, which has a cookie field. Then put it in your server browser or game client, and it just works. Future-proofing game servers. We already support a bunch of game protocols, game engines, networking protocols. So RightNet is quite used a lot in the field. Minecraft Bedrock uses it. NNet is used. GTA 5M uses it. UNet and Unity Transport. They are the frameworks by the Unity. They are used in the Unity engine. We have Source Engine protocol. It's for games made by Source Engine or most of the Valve games. We support Unreal Engine networking, mirror networking, or TCP connections, or any customer-specific protocols. We also have some games, existing games. We protect existing games. They are mostly for hosting providers, but they also use some of these protocols. So these are widely used in the field. If you want to build a multiplayer game, we suggest that you should be using existing solutions because they are mature. I mean, they prove their existence. They are good enough usually. How can you be under our protection? I mean, we can filter your packets and send you via GRE, generic routing encapsulation, at the network layer. You can be peer of us via BGP peering. We can deliver packets via BGP. Or you can use our cloud instances. We have virtual machines, bare metals. You can use one of these in our edge locations. To conclude, multiplayer games need protection. Like if you are building a multiplayer game, sooner or later you will need it. And we offer protection for any kind of DDoS attacks. And attacks are often multi-vectored and complex. They are getting complicated and complicated, and attackers are not stopping either. If they see that they cannot pass your firewall, they come with a new method. They invent it. They are quite smart actually. And volumetric attacks are requiring vast infrastructure to mitigate. botnets create too much volumetric attacks. So volumetric attacks require vast infrastructure to mitigate. And we protect against volumetric and complex attack. We are protecting always. It's always enabled. Yeah. Thank you. Anybody have a question about? Yes, please.
I have a question regarding these 4 options that you named, how to prevent the attacks.
Yeah.
Cookie-based exchange with the server, pattern recognition. And my question is like, you didn't mention much about comparing them, which one is the better in terms of the latency, in terms of effectiveness, and define the attacks and so on. If you could add a couple of things.
Well, we try to use most of them at the same time unless they conflict each other. So we use cookie challenge, but we use cookie server query caching at the same time. Also, we put rate limiters and wherever possible other mitigations available. So we try to define as many our mitigations as possible.
But each one of them adds some latency, extra latency, right? And,
it's in microseconds, by the way. Each of these mitigations, we watch our metrics. They are, for the technology, we are using XTP, eBPF. It is very performant, so it's not like even a millisecond. It's like microseconds.
So for let's say, methods, it's just less than a millisecond.
Yeah, it's less than a millisecond.
Nice.
Any questions? Andy?
Yeah, maybe I give some comments just to your answer. So, basically, definitely the processing for the packets is just in microseconds. Of course, each countermeasure the complexity, especially regular expressions, because it's pretty much resource, so it consumes especially a lot of resources. But on opposite side, what we are doing, first of all, we use the Hyperscan library, and if you check our Gcore GitHub, you can find our integration of Hyperscan into the kernel. So if you have some projects that need to call for Hyperscan library just from the kernel, because the Hyperscan is the user space part and eBPF is a kernel space part, and you should somehow interconnect each other. So we have this implementation, it's available, so anyone who works with XDP can use it for free. And another point, that because we have a distributed infrastructure, usually each node is not processing too much traffic. Because usually the DDoS attack, especially the bot attacks, which is most volumetric, is more or less widespread. We are cleaning the only small portion of the traffic per each node. And if you're interested in the performance, we have an article, just Google it on our site, where we did measurement of the performance of Hyperscan library for different type of the packets, different packet sizes, and what I could say that packet sizes with size about 500 bytes on the server with previous generation of the Xeon, and for Mellanox cards we reached the performance about 400 gigabit per second. That's the performance of the cleaning. So, but basically, as I said, Gcore has a very big infrastructure, and the traffic which we can see, and the profile of the traffic, because we're CDN and hosting provider, is 80% outbound, because the people downloading resources from us, and only 20% inbound. It means that we have a huge free capacity for the inbound traffic to process DDoS attacks. So that's all. If any questions?
Yeah, I also would like to ask you, like from your experience, have you seen like attacks for like economically wise when the attacker spends less than on Gcore in terms of just pure computational resources you spend more to prevent these attacks? It's basically maybe about the package.
Well, usually that resources is free of charge for us, if to be true. So because what we are targeting is the integration with our CDN infrastructure. So as you know, one of the products that we have, if you know, of course, Gcore is the CDN. And why we choose so at the beginning of our DDoS protection project, we choosing between DPDK and XDP. We choose the XDP because it's easily integrated with our existing infrastructure. So we're getting this DDoS protection just free of charge. We reuse the resources that we already paid for, like a CDN resources.
I'm asking more internally, not to the external users, but like economical and infrastructural, what you see from your experience.
No, we never, well, basically we never purchase infrastructure for DDoS protection. We always reuse existing ones. So if we have an infrastructure already for hosting, for CDN, we reuse that infrastructure. And because we use any casting, so it's when we just spreading the load around all our data centers, we never ever face the problem when we exhaust our capacity.
So you have preempted infrastructure, and also you have diversified business model where you can balance between different use cases.
Yes,
so,
yes.
Okay, good.
Okay. If no more.
Thank you. What? Any questions? No? Okay. Thank you all for listening.